So, welcome again. Today is day two of our online networking class. So, to just begin, I would like each and every one of us to do a little recap, provide us a little recap. It's always Joshua that will start. We'll change the flow later. So, Joshua, we will take a little recap on what we did the last time.
Hello?
Yes.
Yeah. Yeah, last. Hello?
Yeah, go ahead.
I'm trying to make my way. That's why.
Trying to make your way.
Yeah, I'm trying to make my way home.
And how far are you from home?
Yeah. I'm already in.
Okay, then while you settle in, run off, take the flow. Joshua will run off there.
Hello?
Yeah, run off. I get it.
Yeah, I say I'm Randolph here.
Yeah.
Not question for the first week.
I'm not getting.
Say I'm Randolph here. And I will not question the first week because I have difficult.
Run off. Do you care to speak a bit?
Hello?
I'm not getting you.
Is it too loud?
Yeah.
Yeah. You get me?
Yes.
I'm Randolph here. I was question the first week of the class.
You are not in for the
Yeah,
first day of the
I
class.
guess.
What you saying?
Yeah, I will not question.
Yeah, but we share the video, right? And we'll ask you to watch the video.
Yeah, yes. Once the video, what I saw on the video, what are you seeing there? You are discussing the introduction of networking.
Okay.
We discuss the introduction of networking. The what is networking. You know how even defining networking. Hello.
Okay. And when we define it, you care to just say what we said instead of just giving outline on what we did. Just what we said and why it is. Just anything.
Hello.
Yes.
Yeah.
Yeah, I said we define networking. That's true. But what definition do we give it? Do you care to just go in, how do you call it, a little more detail what we say about it instead of just giving the outline?
You have more detail about networking.
Yeah, just what we said.
Yeah, you said that. You said, hello.
Yeah, go ahead.
You said hello.
Okay, that's okay.
Hello.
That's okay. Joshua, your hand up. You want to say something, Joshua?
Yeah.
Okay.
I'm ready now.
All right. You can go ahead.
I'm Joshua Pickett. Yeah, last class we discussed the introduction of networking, which was knowing the definition of networking, and also discuss the benefit of networking. For example, like sharing information, sharing hardware, software, and also we discuss the risks of networking, which is the computer hacker,
Yeah. So
viral attack.
let's avoid the same thing. I just want you to say what we said instead of giving all the outline on what we said, yeah, so that we know that you understood something.
Yeah, yeah. We for the first class, a lot of things in the definition of networking.
Okay,
See,
so
like
let me get an
networking.
okay, Chandra, just hold on, let me give a guideline. Okay, so like this is what this is what I will I call it I would love this is what I would love anybody to say. Uh all right, we did talk about networking. We said bringing two or three computers coming together to share resources, and we went on to discuss the types of network. We talk about the two categories of network, WAN and MAN. So these are the things I want you to say, not generally giving outline. So Joshua, you can continue. I just hope that. Hello, Joshua?
You can hear me?
Yeah, I'm getting you.
Affair. I don't know who the definition of networking, which is
so that networking is combining two more computers or more devices together to exchange the same data. And again, I'm discussing the type of networking. The type of networking which LAN, and I understood that a LAN networking is hello.
Yes, I'm getting you.
Yeah, I can.
Mm-hmm.
Yeah, I understood the type of networking.
Okay, so don't finish up for the other people. That's okay. Kelvin, can you give us a little recap on what we talked about the other day? What you captured from there? Kelvin? All right. Robert Douglas, go ahead, Chief.
Yeah,
Yeah, go ahead. Continue the video, Chief.
as well.
I said a little recap, a little summary of the other class, the last class.
Oh yeah, so I was in a route. I just want to quiet area, but anyway, no problem. So we discussed basically the security also about networking.
Mhm.
We said that it's not possible that your a particular network be secure like 100%.
Okay.
There's always a possibility that you're gonna have people tampering, like hacking, other things. So you also advise that we shouldn't even find interest in too much of free things. The
Yeah.
application, the antivirus and other things, it better you pay for it because sometimes something that will come there free, you have like the application might be sending information to where they made it, some sensitive information from your phone, without you knowing as an individual. And then we discuss the various types of networking. We talk about local network. We talk about
Okay. Now there you start, right? All right. So that's okay, Robert. I think you're coming in the program now. With Terence, have you spoken, Chief?
No, no, no.
Okay, your turn now.
Yes, as per our discussion this one time, we discussed about networking, how we connect from one computer to another using one main server in order to share information, share hardware. We can use networking like we were talking about the wide area network, the local area network. For the wide area network, we don't have to obviously be in America or like typical example, we give typical example on what we are doing now, like the wide area network. We don't have to be in America or Washington DC. One can be in Washington DC and one be in Africa right here in Monrovia, and we still communicate. These are the benefits of wide area network. Typical example, the local area network talking about connecting few computers or group of computers together in a small geographical location in order to share information, software, data, hardware, and other stuff. Then we talk about how it rigs, how it affects us. And for the rigs, you said that cautioning us that we should always go for durable materials, like those materials that will last a little bit longer for us. Obviously, we know there's nothing that lasts forever, so you advise us that we go for durable material. And obviously, when we are going for software, we are advised to go for software that we will go on, like for application. When we are downloading application, we should always read through the review, go down, so we can know that software or the application is guaranteed that it won't affect us by downloading malware from servers and things that will affect or cause hack into our computer. You said that we can prevent virus totally, we can't get rid of virus totally or prevent hacker totally. The only thing we do, we make it a little bit difficult for them. They won't easily be able to attack our computer or our electronic material. For the local area where you were talking about how people will connect to one another in the same building, in the same office building, like typical example, like our brother Kevin said, he said that in the finance, for example, the finance ministry, that's a complete local area network because they share information from one storage to another, from one floor to another using computers or using one main server. That was what we captured for this Monday. Are you there?
Yes, I'm here.
Are you there?
Yes, I'm here. My microphone.
You were hearing me?
Yes, I heard you all through. I heard you all through.
Okay, that was what I captured for.
Okay, so who haven't spoken? Kevin, you spoken, right? Who haven't spoken?
Kevin hasn't spoken.
All right. Kevin, your turn. Kevin, please unmute your microphone and give us more insight.
Hello? Hello?
Yes, Kevin, go ahead. I can hear you.
Yeah, you hearing me? I'm ready for you, difficult in the class today because on my internet, I don't know if you're getting me clear.
I'm getting you clear.
Okay, so for the past class, what I capture the basic understanding of networking, wherein we talk about we use networking to compare two devices for the purpose of sharing data, and the data it might be software, it might be hardware. The hardware such that you will connect devices within different rooms, and all devices will be able to print from one printer. That's another means of networking too. And we also discuss the benefits of networking, and we talk about local area network and wide area network.
If we talk about local
So
area network and wide area network, you care to just tell us more what they are?
yeah, and we said local area network, it will take place in the same building. Like for example, like we said, like EPA. Within EPA, we have flow one, we have flow two, flow three. So within each flow, we have a local area network that will be able to connect all devices for them to be able to share data. And wide area network take place wherein um we have EPA in Monrovia, we have EPA in Sanicole or outside Liberia, and we want to connect, we use network, wide area network to be able to connect with those offices for the purpose of sharing information.
All right, thank you so much. Thank you for your insight. So I think you've done justice to everybody. Everybody have provided their insight. So just to move on, we all have said almost everything that we stated. So we are all on path. All right. So the other day when we came to class, we we had a very good class. So we talked about uh, what our network was. So we came up to talk about network as it relates to humans and as it also relates to computers. So in our human life, we know what network is. Network is to link with people, to connect with people, so as you all can work on a common goal. Okay, and then in the computing, similar to human, network is the idea of bringing computers and other devices together so that they can connect and share resources. They can share resources and data as we stated. So that could be they could communicate with each other, or they all could share some physical resources like the printers, the scanners, our cameras. So that's the idea of networking. And then we went on to discuss the benefits. Uh, we told you that the main purpose of networking is for them to share their data and resources. And then we talk on the benefits. The benefit of them have to do with information sharing. So users can share information among themselves very easily. Hardware sharing. So one hardware device could be shared among several users of a particular network. And then we talk about software sharing. We say one software on a centralized server can be shared among a lot of users on a particular computer network. So that is it help you with the idea of not going to buy separate software and license for each computer on your network. So we say collaborative environment, so people can use networking to have meetings and then work together on project in large group or smaller groups like we are doing now. We are having our online classes. So this is the concept of networking. We are sharing our resources. I'm sharing my screen with you, and we are all collaborating and communicating with each other. That's the beauty of the networking. So had it not been networking, we wouldn't have achieved what we've achieved now. Then we talk about the risks. So regardless of the benefits, networking has some risks, but the risks are risks that we can neglect in that they are not so much harmful as compared to the benefits that a computer network bring to us. So, for instance, we talk about the equipment malfunction. Of course, whenever you use equipment, even our phones we use, they do malfunction at times. That is something that is beyond our own control. So, uh, equipment malfunction is so you might have some equipment like some servers running on your network and at a point in time they will just they will just stop working. And we said to deal with this problem you always go for stronger and quality equipment. So how you know stronger and quality equipment? By their reviews. So we are not the only person involved with networking. A lot of people are involved with networking. So they have all tested some devices along the line. So like it is popularly said, you can reinvent the wheel. So you just have to go on, check a particular device, know what customer satisfaction it has brought, and then you go for them. Another thing is we say system failures. So say system failure is when your system can't perform the task that it was actually created for, and those can be caused either by natural or our human interactions. For instance, a system could fail because of flood. Heavy water could come and spoil our network system. A system could fail because of maybe the technological problems. A system could fail due to fire outbreak or electrical disturbance. Those we can do away with by putting strong physical structures in place. That's the first thing, and then to have a backup to make things redundant. In that we have a backup of whatever we do, so that when one is off or one is away, we are able to uh, connect with the other. So another problem is our employees. Besides our system failing because of natural causes, our system can fail because of the employees we have. So if an employee of ours is not in line with the organization's goal, that employee can take out sensitive information and then share it with people who are your rivals, or people who are against what you are up to. So those employees, disgruntled employees can be even the cause for hackers to enter a system. Like for what we know, hackers, the first thing hackers want to do is to enter the easy way. So the most common way hackers can hack into our system is by getting the information they need right from us, either directly through us or indirectly. So that's how. So when you want to protect the human aspect of it, uh, you have to use proper hiring and firing procedures. That is, hire employees who you duly trust, fire employees who go against the organization's policy. Okay. Another thing is computer hackers. We say yes, hackers are normally into what we have. So what will happen is you just can't do away with them. So all the other things you protect. You can also protect hackers by putting strong security measures in place, using strong passwords, using up-to-date equipment, always updating your software. That is the patches that come from the software manufacturers to always install them. Make sure that because the idea of update is a manufacturer will notice a leakage in the software, and then they will decide to create a patch. So always run those patches and then be able to be up to date with the software manufacturer. Uh, Virus attacks are another threat to our network because we know exactly what viruses are. They come into our computer with the intention of bringing us damage, and damage is what we don't want. So these kind of attacks, these kind of viruses are avoided by the use of antiviruses, and then by avoiding the use of certain devices like your network. You make sure no employee is using any pen drive or any storage on your network. So like in some network, you don't carry your computer there. You don't use your personal computer. So the computers that are assigned by the IT officers are the ones you use. So you don't use your personal computer. You don't use flash drives. So that's how you protect, and that is not even it's not only protecting you from viruses, it is protecting you from taking information out that does not belong to the people outside. Another thing is you can use firewalls. So what firewalls will do is they stand between your network and the outside world. So firewalls will filter your traffic that goes out. It will filter the traffic that comes in. So you can set your firewall rules to accept certain traffic or to reject them. So having said that, We went on to generally agree that yes, networking in computer have brought up more benefits than the harms it caused. So it makes more sense that we use. It makes more sense. It makes more sense that we all use computer network. So we'll continue. We better continue because the advantages surpasses the disadvantages. So that was why we talked in terms of the network. Then we went to understand the type of network. We said network can be in two major categories, either a LAN or local area network or WAN or wide area network. So a local area network is just a network that have just the computers connected side by side, not far from each other, usually in a building, in the homes, and it could be in schools. So we went on to list other networks. A wide area network can be a network that go across a long range of distance. So the computers and devices are far apart. In that, so a wide area network will require special devices and special technologies to get it implemented. So we talk about the metropolitan network. This is a network between cities. So a network that connect devices in a particular city at different locations. We talk about global area network, a network that is situated without global limit, so it span across countries and continents. We talk about personal area network, a small local area network that is just limited to a specific person, such as their home. We talk about campus area network, a network that is specific to campuses. So before we move further, I would like to ask if you all have a questions. First take Terence. Terence said he have a question, so the first person will take is Terence. Terence, you can unmute yourself, chief.
Yeah, I got another few questions. Like you were saying something about firewall.
Yeah.
Yeah, for some of all that don't really actually get the entire background of the networking aspect, so we would like you to just whether it is a, if it's a software or it's a hardware stuff, so you can go over it. My next question have to do with the wide area network. You talk about the wide area network.
How do
So
how do Terence?
yeah,
Let me answer it one by one. Yeah.
yeah, okay.
Okay. So a firewall can be a hardware or a software. So this is it. There are softwares that are built to work as firewall. Even in our computer, we got something called Windows Firewall. So there's a software that can work as a firewall. You can configure a filter the traffic that come into your network or go out of your network. In our case, the traffic that come to our computer and go out of our computer. Firewall again can be a physical device. So the networking companies go on, they produce a physical device called a firewall, and then they embed a firewall software in it. So that device is attached to a network and it serves as a barrier. So a firewall can be a physical device or a software. So like bigger entities will go on to buy the physical device because it provides more security because it is made for that purpose specifically. Or they can buy also you can buy a software and then run the software on your network and run it as a firewall. So a firewall can be either a software, it can be a software or hardware device. You get that point, Terence? I don't want you to mute your microphone because I want.
Yeah, yeah, I get that point. And another one,
Yes.
you said I was asking about yeah, what are those special devices or technology that are used in wide area network?
Okay. So in wide area network, for instance, you will see people start to use fiber optic cables instead of the regular Cat5 twisted pair cable that will be used you can use to connect their devices around. They will be using fiber cable. Uh, Another thing is you'll see them they start to use wireless communication, like they start installing satellite dishes. So they will plan a satellite dish here. They plan another satellite dish at a particular location to transmit the signal at a very long distance. If it was just the regular or the computers that are not far from each other, are just normal cable, normal twisted pair cable, we call with the RJ45 connector, you can just connect the devices there and you are good to go. But with very long connection, you have to be thinking about the technology that will support it. Like what I stated, you have to use fiber optic cable, or you have to start using the radio wave. That is, you have to be using satellite signals.
Okay.
Sure.
And another one has to do with the issue of the entire network fundamental that you are talking about.
Yeah.
I understand as when I was going through the manual that you guys sent to the group chat, I was going through and I understand that there are some parts we have to know, to like some practical aspect that you have to display so we can see
Yeah.
for ourselves.
Yeah.
Will that really be done?
Yes, that will be done. So
Okay.
at some part of our class, I will turn my video on, and then we ping the video to your screen, and then you'll see me demonstrating. Specifically, we'll reach to a point where we'll be discussing our networking media and devices, and so I will have to display the ones that I have, and then we'll reach to a point where we'll be cramping cable. So the physical
Mm.
cable will be cramping it, will be we'll be putting it in the RJ45 connector. So that I will have to do a video session so you will see it.
Okay.
Yes.
Thank you.
Another person with a question? Kevin, you have a question? Joshua, Randolph, the both Randolph, do you have questions?
No, no, I don't have a question.
Okay, but if you don't have a question, then
Yeah,
yeah, Randolph.
yeah. For me, my network was giving problems. So while you were discussing, I did not get it.
Wow, discussing at what point?
No, my network dropped, so I have to reconnect.
Yeah, I saw so. I saw so. So at what point you think? Basically, we're just talking the thing we talked the other day.
Uh, I joined her not too long.
Yeah, so that just the same thing we talked the other day. We haven't started any new thing. We're just discussing the the past things we talked.
Oh,
All
all
right.
right, we can continue.
Okay. So going further today, we'll talk about networking topologies. So when you hear topology, the thing that should come to your mind is how our computers or how our devices are laid out, how we physically lay out our network, how devices are connected to each other on a particular network. So topology could be physical or it could be logical. So the physical one is how you actually see the computers, how you see them structured, how they are placed next to each other. The logical part will have to be how the computer appear, how the network appear to the devices that use it, how that network totally appear. And then we'll be talking about the physical layout, how we can lay out our computers, how we can connect the means through which we can connect our computers. We will talk them and then we get to select which is best for us. And so the common topologies we'll be talking about will be the bus, the ring, the star, the mesh, and wireless. So when you look in the on the side of the slide, you'll see them a little bit explained about me in their diagram just a little bit. So we'll go now to look at them individually. So the bus topology is what we normally refer to as a linear bus. So that is the devices are connected on a network using one straight single cable. So the cable run from one direction to the next direction, from one end to the next end, and all the devices are connected to it in a kind of bus form. So at this junction, one device connect. At the next junction, another device connect at the next junction, another, but it's a straight. So the main cable is a straight cable. So the connectors they normally use are in the shape of T. So they are in the shape of T in that uh, okay, the connector used to be T connectors. I will show you what the shape T is explaining about when we go to the next slide in a diagram. But the bus topology entails a straight line, a straight backbone, and then that backbone is feeding the information. So the traffic is passed through that backbone, and then all other devices get connected to it in a linear form. So at one point, one device is connected. The next point of the line, another device is connected. Another point of the line, next device is connected. So coaxial cabling were the ones that people really used to use at the time. So you see the 10 base 2, 10 base 2 coaxial cable or 10 base 2 like a base 5 coaxial cable. The difference between the two was just simple. 10 base 2 mean this cable used to transmit 10 megabyte, 10 megabit byte per second, and it could go a distance of about 200 meters. So when the cable run more than 200 meters, that means you have to add something to boost the signal because it will get weak. So 10 base 2 cable, that's how it used to be. 10 base 5 cable is the same cable. It transmits 10 megabyte per second speed, but then it used to travel at a distance of about 500 meters. So instead of boosting your signal every 200 meters, how they call it, you go on now 500 meters. So if your next device is 500 meters or less than 500 meters away, you don't need anything between them. A straight cable you can run a straight cable from the connector, maybe from the switch directly to the device at any distance between 0 to 500 meters using a 10 base 2, 10 base 5 coaxial cable. Using a 10 base 2 coaxial cable will mean you can connect devices at a distance of about 200 meters. It could be 200 meters or less. So when the distance cross 200 meters, you have to boost the signal along the line. How many of us have taken a look at how our LEC cables, how our LEC poles are run? Joshua, you want to provide small insight if you see how the LEC cables are, how the LEC light poles are installed? Why you think so many light poles are being installed? Why they putting there make one light pole here and then take the next one at a far distance, just stretch the cable? Why you think so, Joshua? Hello, Joshua, you there? Okay, Terence.
Yeah, you talking to me now?
I'm talking to you, Terence, because Joshua is not responding.
Yeah, you are saying that once the cable runs, let's say, I don't know how many meter you have to use or certain level.
Terence, you are muted.
Sorry, my screen adding a little bit funny.
Okay. So I was saying, why you think LEC had to make their poles short distances and add how to call it short distances instead of making it too long and then just stretch the cable.
Actually, I wasn't really getting your point. I had a question that I wanted to ask you too.
Okay, so ask your question now.
I wanted you to I wanted you to recap because I understanding something like 10 base 2. You were just saying like 10 base 2.
Okay.
And I didn't understand of 10 base 5. What that actually means.
Okay, so what I was saying is you have to pay attention.
Yeah.
The cables that are used that were popularly used because the bus topology people not really using any longer. Cables that were popularly used during the bus topology was were the coaxial cables. And the coaxial cables you could get two versions. You could get 10 base 2 or 10 base 5. 10 base 2 is a coaxial cable that can transmit 10 megabytes per second. You understand the speed, right?
10 megabytes per second, yeah.
And that was the speed it could transmit data at. The information could travel at a speed of 10 megabytes per second. And then the base 2 means it could go up to 200 meters. 200 meters
Yeah.
physical distance. So the information could travel that high speed of 10 megabytes per second for a distance of 200 meters. So by the time they exceed 200 meters, the signal get weak. You get it?
Yeah.
10 base 5 is the similar thing. It means it used to transmit 10 megabytes per second, the same thing, but then at a total distance of 500 megabytes, 500 meters. So once it crossed the distance of 500 meters, then the signal lost. But there are technologies that can provide for it. So when you reach a distance of 200 meters, and you are using the 10 base 2 cables, and your devices are still far from there, along the line, there were devices that you can use to boost the speed. So that is why I made special reference to LEC. The reason why you see LEC meters are closer to them is because they are transmitting electricity. And when the electricity travels a distance, it loses the power.
Lose power, yeah.
Yeah, so that's why they make the light poles short, so that at maybe 100 meters, they put one transformer or they put one booster, one regenerator there. So once the electricity reach there, it regenerates it and then it send it again with the same speed.
Okay.
Yeah, but if the distance is shorter than the 100 meters, they don't put any booster, so that means it can reach to the destination with the same speed.
With the actual speed.
Actual speed. So that is the same thing we're trying to explain with our cabling. 10 base 2 cables could transmit with a speed of 10 megabytes per second, but for 200 meters only. Once the distance crossed more than 200 meters, it will lose speed. The speed will drop. 10 base 5 cables could transmit information 10 megabytes per second for a distance of 500 meters. So you see, that was the difference. Two of them transmitting the same speed, but one can travel far and the other can travel lesser than the other one. You got it?
Yeah. Yeah.
So to illustrate what our bus topology look like is on your screen. You see it there?
Yeah, we are seeing it.
Okay, so the bus topology entails a straight line. So this straight line is the backbone. A straight cable is ran from here to the next direction. You see my mouse moving, right?
Yeah, I see your mouse going back and forth.
Yeah. So this bus topology is from here straight to the next place. And along the line, you see here one computer connect, here the next computer connect, here the next computer connect. So the reason why we said they use the T connector is because here at this junction here, at this straight path, they need a connector that will look like T. It's just because the connector look like T that why they call it the T connector. So it will connect here and then it will connect here. So you see it look like T, right?
Yeah.
Yeah, so even here, it will connect from here and then it connect the device here because it have to get signal from this point and transmit the signal to this point. At the same time, transmit the signal to this computer. So the connection look, the connector look like T. So that's why it's called a T connector. So that's how,
yeah.
Yes?
Almost in a form like the similar typical example you are giving concerning the LEC current and thing.
Yeah.
Right? As certain cable will transmit certain current like 500 meter and thing. Because of that, if they go further than 500 meter, then the power will drop because they don't want the power to drop. So they build it in the form of T connector, then it would allow it to transmit another sync or speed to the next sync computer to run the sync.
Yes.
Okay.
So here that's what the bus. Kevin, you specifically were concerned about the diagram. Are you getting what the diagram is saying? I'd like you to unmute your microphone, Kevin.
Yes, I'm getting what the background is saying.
Okay, so the diagram is illustrating well to you, right?
Yeah. Clear.
Topology, this is why it looks. There is one long line, one long cable that is transmitting the information, running, and then all the other computers get connected to it at different points.
Yeah.
Yeah, so that's why the bus topology is. And then the next topology we want to talk about is called the ring topology. So just like the ring, just like the name ring, so the connection is, the signal is sent in a circular form. Terrence, your hand is up.
Yeah, concerning the bus topology you were showing during the diagram.
Yeah,
So where does the main line originate from?
it originates at any point. It could originate from here and it end here, or it could originate from here, it end here. But that is where the signal will pass. It does not require you to get a specific place. If that here your
I'm not talking about where it will begin from. Like you are saying something like Terminator or something. Yeah.
terminator could be the end of A. It's just understand terminator as just the end of A. So
To
it
terminate, to get rid of something. Yeah.
to end something at a point.
Yeah. Yeah.
So it will terminate here. That means it will end here, and then it will end here. So the signal could come from any other direction.
Okay. Thank you.
Yeah. So the next topology is the ring topology. So the ring topology, uh, the information or the devices are connected on a ring. So the main cable, instead of running straight now, is done in a ring form. So all the other devices just get connected to the ring. So at certain point of the ring, one device is connected. At the next point of, let me show you the diagram. At the next point of the ring, the next device connected. So that you see there is this main line. The main line is this running here. And at any point of A, one computer is connected, the next computer is connected, the other computer is connected, the other computer is connected. So it's just a round and circular ring that all other devices are connected to. So the ring, when data is sent, or when an information is sent, it will travel around the ring until it reaches to the computer that it is meant for. So that's just how it will go. And we used to there used to be a way to either do a single ring. That means the information will move only in one way. It will move only in one way like this, or a dual ring. That means there will be another ring in the middle here. If I would draw that, annotate that, there will be another ring in the middle here. So one of A will send information like this is sending information in this direction. This will send the information in this direction for fast flow of information. So topology, again, is just the way your physical computers and devices are connected. So again, the ring topology indicates that devices are connected in a circular form. Uh, the information is sent from one device and it how they call it, the information goes around until it reaches its destination. So you could use a single ring that all devices on the network share one single cable, or you could use dual ring. So whereas uh, the information can be sent in both ways. One ring sending information forward, another ring is sending information backward. Any questions so far on ring topology?
Yeah, I want to ask something.
Yeah.
Do they have the special cable then that you will use, like for the bus topology? They get special cable that you will use to connect in the T form, or for the ring topology, they get special cable that you will use doing the ring topology.
No, that just the same. That just the same cables. It's just the way you will just run them. That's all.
Okay.
But when devices get connected to it, they can like in a T. When you want to connect a device to the main line, that means you have to use a connector that is the T connector that will join the two ends to your computer. Like I was saying again, here is it. The T connector have any of us seen a masoner, a plumber doing plumbing.
Yeah, they got a T pipe.
The T, okay, just as they have that T connector, that T pipe, that similar way. So that means you have to cut the cable at this end, call it at the net end, and then join your connector. So that connector will join this cable from here. It join the signal here, and at the same time, it join the signal to the PC. You get it? But
Yeah.
the same type of cables you're using, you're just using the same. It could be your coaxial cable or your fiber cable, just the same. But coaxial cables were the main ones used for this bus topology.
All right.
Run up, Dolo, your hands up. Please ask.
Yes.
Yes.
Yeah.
Yes.
And we talk about the ring topology.
Yeah.
And you said that the ring topology, I connected in a circle.
Yeah.
And then as I see the diagram,
Yeah.
data flow from one computer to another computer until it reaches all the computers.
Yeah.
And in this case, does it have a main server there? And I also want to compare it with the local area network, because the local area network are connected the same way, where you will send command to another computer, like where we are from server 1 all the way to server 10. But if you want to send information or forward information to another computer where every one of them are connected, you will send that information directly to server, either server 2 or 3. If someone want to access information, you will enter using the internet methods to get information from another server. So in that case, I really want to know whether the working line the same way as the ring topology does.
Okay, so this is a topology again. Understand topology as just the way, the physical way your computers are connected, how they look in a connection. So topology, any network could use, it depends on your network need. You try, you will tend to implement whichever topology you think is best for you. So you can use the bus topology for a local connection or whatever connection, but it depends on how you want it, because each of them come with advantage. For instance, if we use this the ring topology, what will happen to your signal if there is a major cut in the cable from here? Right up.
Yeah.
So if the cable is cut here, that means the communication is damaged, right?
Yeah.
If you wanted to send the information, if the cable is cut at this end and you wanted to send the information from here and it's traveling this way, it will not pass here, right? Because the cable is cut. You got it? Yeah. So this is the idea of evolution. It started like this until people started improving on it. They started looking for ways to connect devices, because all of them you can choose which one is best for you, depending. We'll get to the one that is popularly used around now, and then you will know why it is popularly used. So for instance, let's go back to the bus topology. If I was at this bus topology, and then I use my annotation again. Okay? So, and I am this computer. Terence, I want to make sure you're getting me.
I'm getting you.
Okay, Ranov Kira, Robert Dolo, you there?
Yes.
No, not Ranov Dolo. Now you mean it's Ranov Kira and Robert Dolo.
Robert Dolo?
Robert Dolo. Okay, Robert Dolo here, Chief. Right?
Yeah, I'm here.
Okay,
I'm here.
Ranov Kira. Ranov. Ranov, you getting me? I've unmuted you.
Ranakuya is muted.
No, I just unmute him. Kevin Zokpo, Chief, you hearing me?
Yeah.
Okay, so what I'm trying to avoid, Ranov, you just muted yourself again. I unmute you. I want to hear your voice. You hearing me? Hello, Ranov? The reason why, if everybody's background is not noisy, unmute your microphones.
Yeah, for me, I get a little bit of noisy background. That's why you see the moving up and down in the also. That's why I muted my background. So
Yeah, because the problem, what I'm trying to avoid is the last class time. I had a student who will come to the class and the guy will just connect his phone and just leave it and go.
Yeah, I'm sure.
Yeah, that's not what we're trying to achieve. We want to make sure everybody is here and we can interact, because that's the logic of it. You can so that's why I'm trying to avoid. So I want everybody to partake as much as they can, so we know that we all are here. So you get my point, Terrence, right?
yeah, I get your point.
Yeah. All right. So moving further, I was trying to demonstrate in this bus topology. Imagine Emmanuel is this computer. You see it, right, Kevin?
Yeah.
And then there is a data signal coming from you, Kevin, here. So what will happen if this cable cuts between here? You see the place I'm marking?
Yeah,
Yeah.
Yeah.
Then I mean that information
It will not,
will be cancelled. It won't be.
not reach to me, right?
It won't reach to the destination.
Yes.
Yeah.
So the destination, that destination is me. Is that my computer here, and I'm trying to get information from Kevin, who is PC1 here, and the cable cut between. I can't get that information, right?
Yeah.
So this is why people went to work and look at the topologies, the various ways people get connected, and see. So along the line, it started with a bus topology, and it started improving. People started improving on it. People started looking for ways to get connected. And so they brought out the circular way of connecting. So and then we'll go to see the other means of connecting our devices.
So
Yeah.
so let me say something. So do you think, I want to know if the bus topology is much better than the cycle, the
No,
ring topology?
no, the bus topology is not much better. It's not even in use again.
Yeah, because please click on it. Please click on the picture. Let me explain something
I'm on the picture.
on ring topology.
Ring, okay. Yes. Yes.
Okay, for ring topology, information can be sent from this computer to this computer if you want to use the right, and information can be sent from the right to the left.
Yeah.
So now, if where you place that out F4 to say cut,
Yeah, here.
if the cable right cut, so the information won't still flow on the right to reach to its destination. I want to know.
It, how to call it, depending on the way you implement it, it can still reach, like I said, we can do dual ring, whereas one of the ring transmit information in one direction, the other ring transmit information in the next direction. But even looking at this, if this cable is cut from here, I can still transmit information instead of going to the right way. I can still transmit information upward, right? It can still go around.
Yes, yeah, that's what I'm saying. Yeah.
So there we tend to appreciate the ring over the bus topology, right?
yeah,
Yeah.
The only distance is long.
Yeah, that's what I was saying.
Yeah, but it's better than the bus. If it was the bus and there is a cut, you will not get information at all. Yeah. So does that help out with your point?
Yeah, sure.
Okay. So we'll go further to the next topologies. The next topology is the star topology. So the star topology is the most common, the most commonly used topology around for our local area networks. So when you're looking at the star topology, it looks just like the bicycle ring, our bicycle ring. Have you seen the bicycle ring with spokes?
yeah.
Yeah. So there is a central point where the gearbox is, right? So each of the spoke is coming from there to the one end of the cycle, the next spoke coming to another end of the cycle. That's how the star topology is. There is one central point where all the information coming from, and each device connect to that central point and carry the information to their point. From here, from
Okay.
yeah. So in larger networks, they tend to use the star topology. star topology, let's go back to the beginning of our slide. When you look here, the extended star topology, this is why it is here. You see my mouse, where it is?
Yeah.
So you see there is one star topology, so there is one group of people, they get their central point that they are connecting to, and then the next group of people get their own central point that they are connecting to, but they all are interconnected to another central point. So that's the extended star that we talk about. So larger entities tend to use the extended star. That is, each section of them are managed separately. The next section is managed separately. So let's follow along with our slide. So like we said, when you look at the star topology, it looks just like a bicycle spoke. So the spokes have a central point. They all coming from there. The place the gearbox can go on the bicycle ring. They will move and go to the end of the ring. The next spoke will move and go to the next end of the ring. So then you see what the star topology is. You see the illustration. Yeah. So there is this central point, either a hub or a switch here. So all the other devices get connected to it. One device take the signal from here, it carry it. Another device take the signal and carry it. So what it does is, if this cable is caught here, it only affects that device, right?
Yeah.
It only affects that device. Yes. So it does not affect the other devices. If the other cable too caught here, it only affects that device. You only need to change the cable.
Yeah.
So you see, it have not had, how they call it, it have not had some kind of, it had now an advantage over the previous topology. Over the ring, right? Like the ring had it had advantage over the boss topology. Later we went to the ring topology, and then now the star topology. Star topology have had an advantage, and this is the most popular topology around that we use in our homes, in our schools, in our offices. This is the most topology we use. So can we move forward to the next topology?
Yeah, no question.
Yeah, for this, guys, for this topologies, it's simply trying to say these are topology.
Yeah?
Terrence, am I getting you? Your line is tripping.
It's simply trying to say these are advancement in the topology, right?
Y'all say again, Terrence, I'm hearing you, Chief.
Yeah, I'm trying my network. I said these topology are simply trying to say they are the stage they are from one stage to another.
Yeah, so that's like the evolution. The evolution. It started with
evolution.
It started with my own internet is starting unstable. Can you hear me clear?
Yeah, get me clear.
Okay. So that is an evolution. It started from this point. The improvement went to the next point, and then the improvement, even added, it improved. So like we started with mobile phone, started with 1G, we went to 2G, 3G, 4G now, and then 5G that we just having implemented around. You get it, right?
Yeah.
Yeah. So one of it has advantage over the other. But then after our star topology, we go to the next topology. The next topology is the mesh topology. So what the next mesh topology is, the mesh topology is a topology that connects everybody to each other in a redundant way. Everybody is connected to each other. So it is used for, how do you call it, for wireless, for wide area network, so that they can interconnect local area network for mission critical networks. So like for banks, financial institutions, like our research institution, people involved with large data that other people are feeding on, they use the mesh topology. In that one device gets more than 3 ways of getting connected to the main point. So what it does is it creates redundancy. That is, it gives you more ways to get connected. It gives you more backup power. And this is really expensive to implement. Let me show you what the diagram is. You see what the diagram is? Can you see it clear? What do you call it? Zupo?
Yeah.
Yeah. So
everybody connected to everybody.
To each other. So if I was getting signal, through this place, and this place is cut, I still get signal from here, signal from here, signal from here, right?
Yeah.
Let's understand this thing to be this for Kelvin. This is
Mm-hmm.
Randolph.
Yeah.
This is me here. This is Terrence here. Anybody who leave, will find space for you later.
Yeah, Robert. The next person is Robert.
Okay, Robert, yeah. And this is Robert. So what happening here is this: if Randolph, the two Randolph, if the two of them,
Yeah.
if the two of them were getting connected or were getting signal, the signal they were working with was coming from Robert, and all of a sudden, the signal from Robert got cut. There was an interference between A. There is still a way they can get signal from Robert, right? Because Robert is connected to Kelvin, and Kelvin is connected to Randolph, so they can still get
Robert, yeah.
they can still get the connection through Randolph, so it can take
Mm-hmm.
another direction, because the banks and those institutions can't tolerate downtime. Okay, imagine an institution that is running the GPS or that is running weather forecast. Why we're happy if this GPS go down for just 1 minute? We'll have plane crashing in the air, right?
Yeah.
Yeah, because they depend fully on the GPS for their navigation. They're not seeing in front of them. They can only see in front of them when the team is already closer to them, and that they can't dodge. So they depend wholly on the GPS system to tell them where they're going, and then to tell them who is coming ahead of them at what point to change direction. So if that system go down for just 1 minute, we'll get chaos around the world. So those kind of systems don't take downtime. They don't tolerate downtime. So that is why they are all interconnected. They use the mesh topology. Either they don't want anybody to lose signal. If one side is, how they call it, if one side of A is cut, we use another part of A to run signal. Have anybody been in a server room and see a server computer that have more than one hard drive? It's called RAID. Have
No,
you
no,
seen?
no.
Okay, there are some computers, powerful computers. Powerful computers do processing parallelly. In that they do everything on them is either double or more than double. Hard drive they get more than one. That's the power of the several computers we got around it. Hard drive is more than one. CPUs are more than one. RAMs are more than one. So what they can do is they create the same information. So if one computer has 10 hard drives, which is RAID 10, if it has 10 hard drives, all the hard drives contain the same information. The same information that on hard drive 1 is the same information on hard drive 2. So if hard drive 1 is down, then they can work hard drive 2 and then replace hard drive 1 with another working hard drive. You get the rationale from it? What other illustration I wanted to make? There are some other.
Yeah. So
yeah, you're trying to say something.
yeah, Robert. I just want to know, you talk about computers. So what are those computers you think that have a kind of that is built computers that are built in a way where you have the one hard drive?
Oh, there are the servers. Most server computers run more than one hard drive. You have not been.
Yeah, we
You
have.
have not been fortunate to see it probably. Most server computers run more than one hard drive.
Oh, okay. So it doesn't matter which brand, it's just about server computer.
How do you call it?
Okay.
You know, all the computer companies get their powerful computers and get their less powerful computers. Even the computer you might be using, they all might have their servers. They might have some other computers that are powerful that they run more than one. I have a laptop that runs 2 hard drives.
Yeah, that can be done. You can use that too, maybe using the expansion slot.
Yeah, the guy expansion slot. But for the one, for that one, what you saying? For that, they are all the 2 hard drives there are used for separate purpose. But for the other for the ones who talking, all of them are used for the same purpose. The information that is on hard drive one is the same information that is on the second hard drive. So that when one is down, the other one is working. You okay? Have you had a chance to understand how Facebook, Google, and YouTube everybody work?
No, no, no.
Say, come again.
Facebook, Google, YouTube, those big enterprises. You know how they work. You know what make them so powerful?
No.
Redundancy. So you will be surprised to know that Google have one of their servers in your country, the bureau. So what they can do is those companies that we send our high-end data to that we depend on, and they have to guarantee that that data is safe with them forever. They have their center. Okay, you okay? Noise are coming from your end. Okay, so they have the workstation. They have the centers. Their centers in different countries. Some of them, like for Facebook or Google, is they might have their centers in all the continents. It might not be in all countries, but in all continents. What they can do is, if you are from Liberia and you want to get, so all the server rooms, all the data centers, they will call it all the data centers. Like one data center in Asia, another data center in America, maybe two or three in America, one data center in Africa, or one data center in how you call it, just another continent. They will have all the and all those data centers got the same information. So they replicate the same information. So if there is fire outbreak in America, the data center that is in Africa can work out, right? Randolph, you getting it?
Yeah, you can. Yeah, it
Yeah.
will work.
So that's what they do. So for us in Liberia, if we want to access Google, some of Google services, and we search, it doesn't that data don't have to go long distance. The data center from Liberia can serve us. So it make the connection easier for us. It make it fast for us. Just like in a diagram we see here. If you
Yeah.
connect, if you are from this computer and you want, if you have a Randolph end or Rubber end, and you want to send information to Randolph, the closest path to you is to send it straight to Randolph himself, right? But if you are interconnected and there is a problem with the straight path going to Randolph, that means you can send it to Terence and Terence send it to Randolph. Or you can send it to you can send it through how do you call it the next person who else we got here? Kelvin.
Kelvin.
Send it to Kelvin and
Wait.
Kelvin will reach it out to Randolph. You can pass it through Kelvin to reach it to Randolph. That's the idea of it. So you see, this is reliable, right?
I want to know something. I want to know something.
Yes. Ask something.
Between Robert and Randolph,
Yeah, between
you have
Randolph and
cable cord.
yeah.
Cable cord. But you are Randolph, you want to send a data to Robert. Passing it to Kelvin, will you need Kelvin approval or you need to use Kelvin cable line? You pass it to Kelvin cable line.
So once we are all interconnected, I mean we already agree. You don't need approval basically. We already agree. That's why we are all interconnected. So I can use your path to reach the other person. Clear for you?
Well understood.
Yeah, okay.
Yeah, well understood.
All right. So then we that is it for the mesh topology. And the mesh topology, like again I said, bigger entities like the financial institutions, they only use the kind of topologies because like they get their tellers connected. So they want to make sure that tellers are connected to the main server that serve their database in multiple ways, so that when one line is down, they will still be connected to the next line, because you can't have a customer in front of you and you're trying to serve them, then you can't get connected. No. So the kind of institutions try to implement the mesh topology because it is reliable. So we are moving further. Then moving further next, after discussing topologies, okay, maybe that was our interactive session because we asked some questions. You have any other questions to ask, then we can move to our next part. So the major topologies we talked about are the bus topology connected in a line. Then we talk about the ring topology in a circular. We talk about the star topology, everybody connected to a central point, and then the mesh topology in the how they call it devices are interconnected. Everybody connected to everybody for redundancy, like you see here. So any question before we move forward?
Not ready.
Okay. So the
Yeah, I just want to make a point.
yes.
Hey, Ime, it's
Yes,
run up. I just want to make a point.
I get you.
Yeah, for what I'm sensing from this point of the mesh topology is that every one of them are interconnected. And then even one of the devices or the connection go down, it will still continue to communicate because they are all connected almost from one computer to another computer. Cables are all connected to every one of them. So even when one goes down, it will still operate.
Yeah, so that one will say that if my hand is connected to you and is connected to how you call it Kelvin, and then you and Kelvin are holding hand. So if my main hand to talk to Kelvin is down, I can still talk through you and it reach to Kelvin, right?
Yeah.
That's the logic, that redundancy. So it gave you what do you call it? It gave you more reliability. When one point of connection is down, another point is used to reach the destination. So quickly, the next thing we want to talk about is networking devices and communication media. So when we when we do network, that means there are devices. Okay. Uh, when we connect to a network, there are devices that we use to connect to a network, and then there are also media. So the devices are those physical things that we use in a computer network to aid the communication, to make the communication possible. Then the media are the channel through which the information pass. So it can either be through the physical cables or it can either be through the air, through wireless signals. So we talk about them. So we're talking about the communication media. The communication medias, they are also how do you call it? Okay, networking devices. That first we'll talk about. The networking devices are the devices that are needed, or those kind of the technologies that we use, the equipment we use on our network for interaction, for communication to go on between computers and computers. The medias are the channel through which that connection is done. So if I need to talk to Robert, we all need a switch. The switch is the device that we two can get connected to. How we get connected to that switch? We use a cable. The cable is the media. You getting that point? Through terminology, the devices, the equipment that are used on a network, and then the media are the medium through which communication is travel. Communication travel. The media are the medium through which communication travel. So specifically, they are the mediators between devices in a computer network. So going forward, we'll talk about the communication media. The communication media, like I said, they are the medium through which information travel over a computer network. So they can be either tangible or intangible. That is, they can be physical or non-physical, how they call it, medias. For instance, the coaxial cable is physical. We can touch it. The fiber optic is physical. We can touch it. Those are the channels. These are the ways we can travel. We can send information. Satellite waves, radio waves, we can see it. We can touch it. It's intangible. So the communication media are either tangible or intangible. So these are the ways signal is sent from device to device. That is the medium through which it pass is what we refer to as communication media. And popular communication media we get that we'll be using are the coaxial cable, the twisted pair cables, the fiber optic cable, communication satellites using radio waves and microwaves. Coaxial cables are not really in use now for computer networking. They have been discontinued. But coaxial cables were even in use even before we could before we could start using doing computer networking. Have anybody seen the TV antenna? The cable that goes to the TV antenna?
Yeah, yeah, yeah.
Yeah, I've seen it.
True.
So when you look here, you see this coaxial cable. Okay, Joshua, no problem. Welcome back. So when you look here, you see the coaxial cable. You seen it, right? That's how the coaxial cable looks. It has insulator. It has a kind of protective shield, and then we have the twisted pair cables. Twisted pair cables are a pair of how they call it a set of 8 cables. Each of them twisted together in pairs. So two pair and twisted. That's the way you're looking at it. We'll talk about them later in detail. So we just pass it on a little bit. And then we have the fiber optic cable. fiber optics, in the couple in the twisted pair, data is sent using electric signal. But in the fiber optics, the data is travel using light. So data is sent in fiber optic using light. That means it travels really fast. Light is faster than electricity. So another media include communication satellite that don't want to use the radio wave, they use the microwave to transfer signal. We don't see it. There is a dish placed at a point, another dish placed to the next point, and then the signal between them is just wireless. So you can choose to implement any of the following media. You can choose to use any of them depending on your network requirement. So coaxial cables, like I said, they have been discontinued. We're not using them any longer. But the twisted pair cables, you want to use twisted pair cables just to connect devices in a particular computer network for short range. So I want to connect my computer to a switch. I connect it. I want to connect my printer to the switch. I want to connect my router to the network. I use the twisted pair cable. Fiber optics cable, we want to use them for long distance. Have we seen fiber optics running around? Have we seen the telco digging the ground around Monrovia and running their cables?
Yeah.
So that is the fiber cable they are running. It is used for long distance. It is used for long distance signal. So the telco is using it for long distance. And do you know how the telco is getting their signal to Liberia? It is through fiber.
No.
Yeah, it's true fiber. Fiber can stand real good tension. It can pass through a lot of environment. It can go in the air. It can go on the ground. It can go in the water. So the telco is getting connected through fiber optic cable. I think it's running from France all the way and terminating at Main Street under the water, under the ocean. So fiber is used for very long connection because it's fast and it can transmit very fast or long distance and very fast signal. So fiber, when you use fiber for long distance communication, and the twisted pair cables we just use it to connect our devices around in the network. So let's go into this a little bit.
So yeah, I have a question.
Yeah, ask your questions.
Yeah, so that means the optic fiber cable, it doesn't have anything to do with the 10 base, the meter business.
No.
So how many megabyte per second they can transmit?
Fiber
It,
cables can transmit up to how you call it, even 1 gig, more than 1 gig, not even megabyte, more than 1 gigabyte per second signal.
how many meters it can transmit information?
It transmits very long signal. I'm telling you, fiber cable that is transmitting information from France here, so you will know the distance.
Oh, okay.
So all of Blue Star or Orange or Lepteco, they're not using satellite dish again to get signal to get their connection. The data is transmitted from France through the ocean, under the ocean. So that while certain part of the ocean, sometimes you can see the people can tell you that no submarine can go there because there where the major data cables are running underground. Okay, how they call it? I come to you, Chief. Kelvin Randolph and the other Randolph. Are you hearing me?
Yeah,
Yes,
clear.
I'm
I'm
hearing.
hearing you.
Please have a little bit of interactive session. Let me settle something for just a minute. Yeah. Hello, man. I told you to interact. You didn't do it. Hello, Randolph. Everybody there?
Yeah.
Okay. Sorry, I have to. Somebody brought me gas to put in the generator, so I have to talk to them. So that is it. Any other question on the coaxial cables, coaxial twisted pairs, fiber cables, and satellite communication? Okay.
Yeah, you were saying some this.
You are coming.
Father,
Like,
the main he said that the he said that the optic fiber cable was faster. So how is it like?
how
When can you use it?
how can we use it?
When can you use it?
When can we use it? What you saying?
But, yeah.
Okay, so like I stated, so let's put all the cables into use one by one. Like we see here, the twisted pair cable, like I said, you can use it for just short communication. Like I want to connect in my house or in my building. I want to communicate. I want to connect my how they call it, my computer to the switch. I want to connect the printer to the switch. I want to connect my computer to another computer. I use fiber up. I mean, I use the twisted pair cable, fiber optic cable. For instance, I am Access Bank. I want to communicate with my other branch in Kakata. Twisted pair cables can go because, like I said, they have how do you call it, they have a distance limit. Like they twisted pair can travel 100 meters, then you lose the signal. So if I want to communicate from my branch in Monrovia to the branch in Kakata, then I run my fiber optic cable. So fiber optic cable are used for long distance communication. They are suitable for long distance communication because they can stay in any environment. They can go in the air, they can go on the ground, they can go underwater. The data in fiber optic is transmitted using light. So just imagine the speed of light. That's the speed of fiber, and it can transmit very large data. You got it, Terrence? Huh?
Yeah, honestly, yeah.
Okay. Round up though.
Yeah.
Okay. So looking at you, if I if I if I if look at you as a network expert, if I need to connect my printer to a switch, which cable you think I'll be using?
If you want to connect your printer
To a switch.
to a switch,
Yeah, which cable you think is durable, is adequate, is good for me?
a cable that will be good,
Mm-hmm.
you can use the coaxial cables.
Coaxial, as well, I said coaxial is not in use again, it's discontinued.
Is then use again.
Yeah,
It's step there.
of course, I use the twisted pair.
You can use a twisted cable also, right?
Yeah, that's the most popular cable, the cable that get there RJ.
Yeah, because it contains a pair of wire, so it's also guaranteed to if you use it, will be hard like to break. It's true because the coaxial cable is sometimes break.
Yeah, and the coaxial cable not very.
Whenever it break whenever it break the connection, will go slow.
Imagine the coaxial cable was transmitting how they call it, was transmitting data speed of 10 megabytes. That's slow. We don't need a 10 megabyte per second cable again. The twisted pair can transmit up to how they call it 100 megabyte per second.
Yeah, because it is more to use.
Yeah, and so it's faster. So you use so that is why the coaxial cable were discontinued. So I want to use my twisted pair cables for just short distance connection, right from my computer to my computer in my room to the printer in the living room. That's where we use our twisted pair cabling. But fiber optics are long distances. That is why you see it's running fiber optics around around our country. So because it travel long distance, it stay in an environment.
Yeah.
Kelvin,
Yeah, I wanna say something good.
yes.
Yeah.
Yeah, Terrence, I wanna say something, Terrence.
Yeah.
Yeah, it is concerning short cable. I stay noticing or stay seeing the second cable TV stay using those short cable running from the channel to the people.
Yeah. Email.
Hello.
Your email is muted. Raymond is muted.
Okay.
Before you read back shortly. Yeah, you were saying something concerning the Kwashiorkor. I didn't hear you. You said I know it's not in.
Yeah,
Sorry. I'm here. Okay, so we're saying.
as you were saying,
Yeah, say what we're saying.
no, as you were saying for the Kwashiorkor,
Yeah.
for the Kwashiorkor, these are cables that we were using way back, and for now it's not in use again.
Yes.
Yeah, because the speeds were very slow.
The speed was slow.
For the twisted cable, it's easier to use and is traveling faster speed than the Kwashiorkor cable. So this is the one that they are using currently, which is a twisted cable. It's easier to use.
Yeah, I'm saying like carbon cable still using Kwashiorkor cable from the external and to the decoder. Terrence, I'm not getting you. Yeah, I said that I'm still using carbon cable.
Your background is so bad, Terry.
Then maybe just type it in a chat area, then I will see it. Okay, so
Yeah, email.
Yeah. So, Iman.
yes.
Hello.
Yeah, Kevin.
Yeah, Iman. So what I understand is that the twisted pair cable is mostly used for local area network, right?
Yes.
And then the optic fiber cable is used for wide area network.
Yes, to connect the networks at far distances. Yes.
Yeah.
So
Okay.
we can also use the wireless signal to connect people at far distances. But any of them that you want to use, you got to see the advantage. The advantage of fiber over the wireless is that wireless can get interference. Bad weather can cause interference in your wireless signal. Long buildings. So that is why when you are at some point to get certain connection, you can get long buildings and long trees.
Yeah.
Can stop the connection. It can stop your wireless wireless connection. Interfere.
Mm-hmm.
Fiber optic is just straightforward. That cable, once you able to lay the cable, once you able to run the cable, the signal will reach there and that's going.
Okay.
So we can move forward.
Yeah.
Right? We'll talk about
Yeah,
cabling.
email.
Yes.
Yeah. You asked me a question. Yeah, you asked me a question that which one of the cable is good to use to a printer, and that question alone made me a little bit confused because the type of connection that I've been knowing about when it comes to connecting to a network devices, yeah, you don't connect the cable directly to the printer because you will use you use the cable to the system, and for the server, every connection will be done directly to the server, and the server will supply to all the other computers. So the server now is responsible to connect the printer to the server. So I have not seen twisted cable connected to the printer.
How you think the printer is connected to? So the cable you can see is that cable with RJ45 cable, RJ45 connector, right?
Yeah.
That's a twisted pair cable. The connector is just
No, you are done.
look here. You see this cable here? Two cables. Everything twisted together in here. You see them how they looking, right?
Yeah.
Are these cables running in that RJ45 connector you see? So that twisted pair cables you can actually use to connect that printer. That printer is being connected to that switch, and that switch that has the server connected to it. That you call it that the twisted pair cables you're using that the connector is just the RJ45. That the twisted pair cables you're using. The next class time you'll see a twisted pair cable, and I will show you a RJ45 connector, and we'll cramp it actually.
Yeah, I know of it. Like the twisted pair cable is the one that you use on the RJ45 before connecting it to the switch or to the server.
Yeah, so that's why I just wanted you to. I just needed to hear from you. How do I connect my printer to a network or switch? So it's just I use the twisted pair cable that is due for connecting the printer to the switch because I just short this thing.
Yeah.
So I want to know something about that.
Yeah, Terrence.
Yeah, that's my first question
I've
is
seen your
chat.
message about Sarcom.
Yeah. Then again, I got another point.
Yeah.
You are saying that local
Huh?
you can connect. You are saying that in a local area network, you telling me that in a local area network, you can connect more than one devices or computer to a single hardware. Like for typical example, like printer. So how is it possible that the thing can play and upon the the last flow, you are
Terrence, I don't
on the
get you.
second flow.
Yeah?
I'm saying that you are saying that in a local area network,
Yeah.
people can share hardware with the people can share printer.
Terrence, why you do chat tap that message? Like so you said you noticed that Sarcom still using the coaxial cable to connect
Yeah,
antenna to the recorder. I don't know about that technology. Probably I can't tell too much. But the last time I was at Sarcom office, I went there to give them internet connection from my ISP. And what we use, we didn't use coaxial cable. How do you call it? I connected uh, the radio down to the router using twisted pair cable. I clamp it with the RJ45 connector. Then from the router, they connected their switch and then they share the internet. But I can't speak too much of that technology. But coaxial cabling uh, was started working for radio communication. So even before computer networking, coaxial cables were in use already. So it's true that Qualcomm is still using it for the radio communication or wireless that too much.
yeah.
I understand the point. Man. Hello?
Go ahead.
Hello?
Yeah, getting you.
Yeah, the reason why he's saying Sagon is still using the coaxial cable is that because when you buy the set, the package, they give you a antenna and a decoder.
Mm-hmm.
So the line are running from the antenna to the decoder.
Mm-hmm.
It has a coaxial cable that you will plug to the decoder for the decoder to receive signal.
Okay.
Mm-hmm.
All right. I haven't used that. I haven't seen it. But that is still a radio communication. Maybe the people doing radio communication are still using it.
Yes,
But
yes,
in
yeah,
computer networking where we connecting our devices, our computers to the switch or our printers to the switch, we no longer use coaxial cabling. But
yeah,
probably Sarcom, they are doing radio communication. Probably because
yeah. Radio communication is doing
it
it.
was radio communication that started using coaxial cables. It was in use even before we could start doing computer networking. So
Yeah,
quickly, yes, somebody was saying. So quickly, we are almost in time. So we want to this we pass our interactive session. We want to talk about the networking devices that we use on the network. We run over this quickly, and the next time we come, we'll go back over it with seeing some of the physical ones that I have with me. So on the network, the devices that aid networking has to include one of them is a hub. A hub is no longer useful. It's no longer used. Like I stated, it started that these are all evolutions. So when we started the communication, hub is a centralized device, and it is used to connect multiple devices on a network. So if you want to connect two, three, four computers in a printer on a network, you use we used to use a hub. So you see the ports down here. These are ports for RJ45 connectors. So each of the device, a cable is connected to your computer and is ran through this through this so if this hub is 8 ports, I mean 8 different devices can get connected to this hub. and a network. So you can expand a hop by connecting one cable here and then another cable to the next hop, therefore expanding your connection. But these hops, they used to receive signal from all the devices. The reason why they were discontinued is when 2-3 devices are connected to a hop, and like for instance, Randolph intended to send me a communication directly to me without Kelvin and Terence seeing it. When Randolph send that communication go to all of the devices connected to that particular hub, connected to that particular network. It will go to everybody, and everybody will see it. The person responsible, the person who it is meant for, will capture the package and respond to it. That which was not really good. After due to that, the next device was brought in called switch. A switch was developed smarter than a hub. A switch, just like a hub, connect different devices on a computer network. But then what a switch did is a switch was very smart. So a switch can remember your MAC address. So the MAC address of your computer is an address that is assigned to your network card. So every computer that can get connected to a network has a network interface card. So that network interface card has a MAC address. That MAC address is unique to you. So every interface card, network interface card has its own MAC address that no other network interface card can get. So that MAC address, the switch can remember. So when a communication is sent, it will be sent using your MAC address. So when it's meant for you, if it is meant for this particular MAC address, it will go directly to you. So switches were really the smarter because they implemented the use of MAC addresses to know the exact destination. Let me see. In a local area network, like a building with 19 Kelvin is on top 19th floor and I am at the second floor. Can we share one printer? Yes. You and Kelvin on different floor, you can share one printer. Because there is a connection coming from your floor going all the way up to get Kelvin connected to your network. So you can share one printer. The only problem is if Kelvin send a print, if the person from 19th floor send a print, they have to walk and come all the way down to the ground floor to get the print. So to avoid that here, what we do is each floor will just send one printer and just put one printer there so that users of a particular floor can just print using how you call it, a printer that is on your floor. So going back to the switch, the switch connect multiple devices on a network, but a switch is smarter than a hub. The two of them performing the same task, but the switch is smarter in that the hub will broadcast the network to all the devices that are connected. So whether it was meant for you or not, you will see that communication. And then the person who is meant for will capture it. But for a switch can send a communication directly to a MAC address to the direct PC it is meant for. And so yeah.
So that means sweep. If you're using a switch and you're using a hub, information or communication is not really secure on the hub, such that if I want to send an information only to you for you to read, and we are using hub to distribute that way, then I mean everybody will see it. I mean Terrence will see it, and the other guys will see it. But once we are using switch, and I mean I will identify your name and send it straight to you.
Yes.
So
yeah.
We can move forward, right?
Yeah.
So we will not. We will not take after here. We'll not take too much questions. So what you do is mark your